We introduce the concept of database saliency in this work. We show a way to find database saliency and use it for creating summaries in the form of mosaics and collages. We wish to point out at the onset that database saliency and image saliency are two different measures. An image saliency value is assigned to an individual pixel in an image, measuring its distinctiveness from the rest of that image, whereas a database saliency value is assigned to an individual image, measuring its distinctiveness from the rest of the database. We argue that in a given database, there are certain images that are more salient or uncommon than the rest. These images often tend to be visually appealing. For example, among the set of images shown in this frame, the firefly image has the highest saliency value, whereas the ceiling image has the least. Now we show the images ranked with respect to their database saliency value. The top left image has the highest, and the bottom right image has the lowest database saliency. Our algorithm for finding database saliency relies on clustering images of the database. So we need an image abstraction technique and distance measure to compute the similarity between two images, i.e. their image signatures. We now explain how a signature for an image from the database is computed using our novel saliency-weighted color coherence vector. Consider the following two images. The bottom image is a scaled and tiled version of the top image. Notice that they have the same color histograms. We partition the pixels in the image into two classes, coherent and incoherent pixels. Two separate color histograms are built for the pixels from both these classes. Further, each bin of these histograms is weighed with the total saliency of the pixels falling in that bin. Notice that the image signature thus computed for both the given images differ. We present two applications where database saliency can come in handy. First, to create image collages, and the second, to create image mosaics. We now give a snapshot of the algorithm we propose to find database saliency and create image collages. Suppose we want to make a collage in a 3x3 grid. We first run a k-means algorithm to cluster the database into 9 clusters. We then rank each image of the database with decreasing order of their distance from the nearest clustering center. We pick as candidate images the images that are placed furthest away from each of the clustering centers, and at the same time match tiled regions of user-provided template images, if any. We join the images together by our technique of finding the best seam cut based on image saliency measurements. As a post-processing step, we blend the images using Poisson matting techniques. We now explain the application of database saliency for creating image mosaics. The mosaics that we create vary from the conventional image mosaics in the sense that size of the tiles that make up the mosaic can vary. For this effect, we propose a novel energy map decomposition technique. Given the user input image, we compute its image saliency map. We partition the image recursively into 4 quadrants using a quad tree decomposition. A quadrant is exempt from further splitting if the total saliency value inside the quadrant is less than the threshold value. At each of the leaf quadrants, we find the best matching database saliency ranked image to fill it. Here, we have taken a video of a fluttering flag and replaced each frame with its corresponding mosaic. We finally present some of the image collages and mosaics that we created.